Hello and welcome to Web Math Academy, where today we're going to discuss an introduction to derivatives, which is an important topic in calculus. Now, the study of derivatives naturally follows our discussion of limits. The derivative is the slope of the line at a particular point of the function f of x and is used in many applications that we will introduce later. The derivative given by f prime of x is given by the following formula. It looks a little complex, but once we try an example, it will be made clear. Let's try a function of f of x equals x squared at x equals 4. In this case, f of x plus h in the formula becomes x plus h squared, and f of x becomes simply x squared. So if we substitute those into the formula, we get f prime x equals the limit as h goes to 0, x plus h squared minus x squared over h. Now if we replace x with 4, because that's where we're wanting to determine the derivative at, we get the limit of 4 plus h squared minus 4 squared over h. If we expand that quadratic out, we get 4 squared plus 8h plus h squared minus 4 squared. And if we collect terms and simplify, we get all the way to the bottom, right here, the limit of 8h plus h squared over h. And as h goes to 0, and as we simplify that further to 8 plus h, we get our simple answer of 8. Now this limit can be used to solve a great many derivative problems, but it becomes cumbersome and prone to mathematical errors in some more complex applications. Thankfully, it has been used to derive some theorems which can be applied much easier. Let's look at some examples. First, if f of x is a constant, such as f of x equals 2 or f of x equals 10, well then we can see that the slope is 0, and hence the derivative or slope is 0. Second, if f of x is linear, such as f of x equals 2x plus 3, or f of x equals negative 10x minus 4, then f prime of x, the derivative, simply equals the slope of that line, which in this case is either 2 or minus 10. Third, if f of x equals any function x raised to the power n, then the derivative f prime of x equals nx to the exponent n minus 1. So going back to our introductory example where we had f of x equals x squared, then using this formula, f prime of x becomes 2x to the 2 minus 1 equals 2x. And at x equals 4, f prime of x becomes 8, our answer. So much easier to determine. Here's some other examples. What is f prime of x of 4x cubed? Well, putting that into our equation, 3 times 4 becomes 12, and x becomes x squared. F prime of x to the negative 5, well that equals negative 5x to the negative 6. Finally, f prime of 1 over the square root of x, well that equals x to the minus 1/2 power. So if we put that minus 1/2 in front of the x and subtract 1 to get negative 3/2, we get our answer. Now all of these results can be verified with our Texas Instruments TI-Nspire calculator. I have some of them set up here right now. You can see here I put the first one ddx. That's another way of saying f prime of x. ddx of 4x cubed equals 12x squared, which is what we have over here. And ddx of x to the negative 5 equals negative 5 over x to the 6th, also what we have over here. So let's try 1 over the square root of x. Go to Menu, Calculus, Derivative, and here we're going to get derivative with respect to x, so we'll put x there, and then we'll simply enter 1 over square root. Here we go. X, enter, and there's our answer. Put in a little bit different form than we have over here, but it's the same answer, minus 1 over 2 times x to the 3/2, which is what we have over here. So these are some powerful tools that you can use to make derivatives easier to apply. Next time we will go over some more derivative rules, such as for adding or dividing various functions.